In this video, I'm going to discuss my two favorite SQL Server wait stats, and although it's limited to those two, you may find some of the information valuable in general. This video does not discuss many other important SQL Server wait stats, but focuses on async network I/O and OLEDB. Even though it is limited to this, you might find much of the information valuable and interesting. There are many other important stats, including, in particular in my experience, CX packet and certain locking wait stats. CX packet certainly deserves a video of its own. Perhaps I'll make one in the future. The video begins with a discussion of dynamic management views and functions, DMVs, which might be a little bit tedious, but hopefully doesn't last too long to lose your attention. We know SQL Server Management Studio does not like to show us some things, such as system tables for a database. It chooses to expose those through views. And if we look at the system views, we'll see that there are many views there, whether or not we have added any user views or not. And that many of these begin with sys.dm. The DM stands for dynamic management. We have dynamic management views and dynamic management functions, but they're generally lumped together and called dynamic management views. The dynamic management functions also return row sets, but they take parameters. We'll look at some of those later in other videos. Now, it turns out that there are a couple of types of dynamic management views. Some of them give us the same result no matter what the database context is that we use. We can run them from any database and we'll get the same answer. They're giving us information about SQL Server as a whole. And if there is database specific information in there, we can put in a where clause that may give us just what we want. There are also dynamic management functions, but you won't find them listed under views here because they're not. You won't find them listed under the functions associated with a user database. They're not there. They exist in one place, and that is in the master database. And if we go to the master database and look at views, we'll see that there are all the other views that are automatically added to other databases that we create. But if we look at table-valued functions in the master database, we'll see that there are functions that do not exist in user databases. If we look at them, we'll see that they take parameters. Now, very often they'll say there is no default, but it turns out if you put null in for the value, you can still get some results. For now, we're going to look at a dynamic management view that is actually a view, sys.dm/os waitstats. If we execute a query using the view, we'll see that it returns several columns and rows. First column is textual. It gives us a wait type, which we have to decode by looking out very often. And it gives some other columns. Now, every time a thread in SQL Server tries to do something, it's either able to do it or not. And when it isn't able to do it, it's because a resource is not available. A resource being something like disk or memory or network resources. And so it comes and it increments the waiting task count by 1, and it adds the time that this has delayed the execution of the thread. It also keeps track of the maximum wait time and the signal wait time, which is a different type of wait that we're not going to involve ourselves with here. I haven't found it very helpful for diagnostic purposes. Now, what I generally do is take and I sort this by the wait time, descending. And I can do this from any database, and it's going to give the same answer. And we notice that there are some here with rather big numbers. We see that they decreased. Many of these are incremented by threads that are performing tasks for SQL Server. They are things that we can do nothing about directly. They may be checking for deadlocks or have something to do with the lazy writers, keeping track of those, but we can't do anything about those. The thing we need to do is find the biggest one that we can do something about. And this takes some experience, and what I would suggest that you do sometime is just go through a number of these and look them up, satisfy yourself like, this has nothing to do with anything that I can directly affect. Unfortunately, learning what individual wait-stat abbreviations mean is not easy. Many versions of SQL Server have added wait stats without much fanfare, and the documentation is often unclear to virtually non-existent. There have been several online efforts to attempt to amass some user knowledge about WaitStats, and most of them have not been particularly successful. However, in preparing for this video, I discovered one that does have some potential, and that is at spotlightessentials.com. One of the menu items at the top of the web page is WaitOpedia, and here you can type in a WaitStat name, or you can view a list of all the wait types, find the one you're looking for, and find a description. Some of these are very helpful. Some of them are not as helpful, but as you learn things, you can add to this database of information, and that would be very helpful. Sometimes you'll be able to state something different, and sometimes you'll be able to state something a little more clearly. In making this video, I have added a couple of meanings for the wait stats we discuss here. To add your comment, you click obviously on the Add Your Comment or Answer button. To see all of the answers, you have to click on the Show More link under the first answer. My answer appears included in that list. One thing that I wish they would do, and perhaps they do, but I can't see where, is to classify these wait stats according to whether they are things you can do anything about or not. Many of them are not, and those are the ones you have to learn to ignore. I'm not going to discuss this any further, but this is a website I think you should familiarize yourself with. I don't think there's going to be any substitute for just going through these from the top of your list of most important wait stats on your server and familiarizing yourself with their meanings. And then, typically what I am trying to do is find the largest wait time for a wait type that reflects some dependence upon queries that I have written, queries that are executing, user queries. There are a number of them, but I'm going to tell you about two of them, which I think are very important because they can reveal things that look like SQL Server is not performing well, when in fact it is not SQL Server's fault at all. So I'm going to come in here and I'm going to look for the maximum wait time, and we see this number is about 32 million. And then I'm going to look for two wait types, one called Async Network I/O, the other called OLEDB, and if we know what they mean, that's good enough. Now, if I execute this, we'll see that this is very small, 0, and Async Network I/O is not very large. What I'm looking for is wait statistics that are somehow connected with something I have control over, which is more than 1/10 the size of the maximum wait statistic. Now that's just my rule of thumb. I look for this 1/10 value. You might determine you like some other value. Now these numbers are aggregated from the time that SQL Server, not Windows Server, but SQL Server starts up. So if we were to restart SQL Server right now, these would all be zeroed out, and they would begin aggregating the ones that SQL Server uses internally much more quickly than you might expect. So the question is, these are the two I'm looking at. I'll tell you a story here. I once did some work diagnosing some problems with a company that had a server and about 3,000 users. These users were using a client-server application that was directly connected to their server. There was no web server in the middle. And each one of these machines at their various stores was connected through a wide variety of connectivity types and speeds. Performance was bad. Queries were slow. When we went in and looked at this Async Network I/O, it turned out to be huge. And when we converted the wait time in milliseconds to seconds, actually to hours, and divided by the number of processors, we discovered that each core of the machine, there were 16 of them, was spending over 4 hours a day in this wait state. I say wait state, wait statistic, showing the statistic. What that means is that SQL Server was trying to send information back through the network connections, many of which were slow, and it could not send it fast enough. It's trying to feed it to the network. The network won't accept it because of either the network speed or because of a very slow machine on the other end. And so these async network I/O counts were stacking up. Now, the really bad thing about it from SQL Server's standpoint is that that amount of time is included in the amount of time registered to execute that query. So the time that is spent waiting to send things across the network looks like SQL Server is not acting very efficiently. This means that SQL Server was adding 4 hours times 16 cores, 64 hours per day to the execution time of SQL Server statements. Now you may say, Joe, there's only 24 hours in a day. But yes, with 16 cores, there's actually a possibility of 16 times 24 hours of execution time for an instance of SQL Server using 16 cores. If there were a website between SQL Server and the end user, SQL Server could feed data to the website fairly quickly, be done with it, the query would look good, and then the slowness would only appear between the web server and the end users across their slow network connections. Now, actually, I have seen a situation where async network I/O was actually very high where there was a web server, and it was discovered that the web server wasn't able to collect the large amount of data very fast, and adding more and faster disks to the web server solved that problem. When there is an adequate web server, slow machines or connections can then despool their information at their own rate without putting a burden on SQL Server to wait for them and interfere with other client code executions. I have seen this several times. I think it is a real issue that needs to be looked at. Very often you'll be told, oh, well, SQL Server is slow. You're seeing statistics that show that queries are acting slow. And when you get right down to it and look at it, you'll see that this async network I/O is very high. And at that point you can say, okay, it's not SQL Server. It's either the network or it is the client machine that is so slow that it cannot accept data from the network. So to SQL Server, it looks like the network won't accept it. OLEDB is the flip side of this. OLEDB wait types occur when the client is sending bulk data, like a whole bunch of updates. And SQL Server there is sitting saying, okay, I got your packet, I got your packet, I got your packet, send me another packet, send me another packet across the network. And the client machine is not sending it fast enough. This is one I've seen less often, but it is one that I have still seen. Now, another query that can help show this is if we look at select star from sys processes. I know this is deprecated. This is a query that will give the same answer regardless of database context. You'll see that it shows the last wait type registered for each SPID. Now, typically, we're only concerned in the wait types where the SPID is greater than 50, because the ones where it's less than 50 are ones associated with SQL Server itself. That is a correct statement for older versions of SQL Server. However, under newer versions of SQL Server, it is actually possible for some of the SQL Server system SPIDs to have values greater than Server right now. And if you discover and you go through here and see that many of these, an excessive number of these, are the same, particularly if they're async network I/O or OLEDB or some other wait type you can do something about, you know you've got a problem. And in the case of the wait stats that I've discussed here, this problem is not really SQL Server's problem. It is a network problem or a client machine problem. I did see a case once where there are 250 connections and 220 of them said async network I/O, and that was a different one than the situation I just described. It turned out that client application was not able to receive the data fast enough, even though the network connection may have been okay. By viewing the output of sys.sys processes, we can see what wait stats are happening now, as opposed to over the entire runtime of this instance of SQL Server. Two wait statistics that I look at very often, typically they're not the first thing I look at, but I may look at them particularly if I can show that running a query on the server and running a query through a client machine give very different times, because running it on the server, it's not going to generally be waiting for the network. So some of the things we've learned from this video are that if we encounter these wait stats. That placing a sufficiently powerful web server with a fast internet connection between SQL Server and the slow network connection and or slow client machines can address this problem. Likewise, you could place a sufficient machine running an object server with a fast connection to SQL Server. This, however, may require a substantial re-architecture of the application. As an alternative to doing that, you will have to increase the speed of the connection between the client machines and SQL Server and or replace the client machines with faster machines. If you like this video, please like, share, comment, and subscribe as you see fit.